Hello, everybody. I guess let's go ahead and get started. We're 2 minutes past 11. Thank you for taking the time out of your day to watch our EMC webinar about EMC partner conducted immunity test systems. My name is Patrick Bolliger. I'm an EMC sales manager here at HV Technologies. Today, we're going to review features and benefits of EMC partner IMU generators, and then we'll jump into a live demo. Everybody's microphones are muted, but if you have any questions, please go ahead and type those in the chat box and we'll review those questions at the end of the webinar. Um, so for those of you who might be unfamiliar with EMC Partner, they're an employee-owned Swiss manufacturer of transient generators located in the Basel, Switzerland area. Their field of expertise is in high voltage impulse technology. The company was founded in 1994, and they've built a reputation for delivering high quality, innovative solutions for EMC testing to an ever growing international customer base. EMC Partners' roots go back to the very beginning of EMC with over 30 years unbroken participation in standardization committees, including active participation in the IEC, the International Electrotechnical Commission, and SAE, the Society of Aerospace Engineers, among others. EMC partner products encompass commercial and industrial immunity testing, indirect lighting on aircraft, military testing, component testing, and other product segments. HV Technologies has been the exclusive North American distributor for EMC Partner since the late 1990s. Our roots also go back to the beginning days of EMC, since our company founder and EMC Partners founder used to work together at another prominent manufacturer of high voltage test equipment before starting their own companies. And we at HE Technologies serve customers in the North American market, so USA, Canada, and Mexico. We handle sales and service activities. We do local repairs, and we run a A2LA accredited calibration lab. And our company is split into two different divisions. We have a high voltage division and an EMC division, and I'm working in the EMC division. So conducted immunity equipment. What exactly do we mean by that? Well, basically what we're talking about is transients. So EFT, burst, surge, and Ringwave, those are some of the more common transient tests for commercial and industrial immunity testing. EMC Partner offer two different multi-function generators, which can be configured for a variety of different tests according to IEC basic standards. And basically the only difference between the two are test levels and test configurations. In these generators, you can have up to 9 IEC tests. So they have a modular hardware design, so a customer can pick and choose which tests they want installed in the test system, and they can also add test capability in the future. So you're not locked into what is purchased at the beginning. You can upgrade down the road, on site even. There's no need to return the equipment back to us. There's a touchscreen controller and integrated AC/DC power line CDNs, decoupling network. Firmware updates are free of charge, and we do take customer feedback and implement improvements as needed. And you might be wondering which IEC standards this equipment can fulfill. So basically here we have it all listed out. Basically the test standards are IEC 61000-4-2 ESD, 4-4 EFT burst, 4-5 surge. That's both a combination wave surge and the 10700 telecom surge. 4-12 Ringwave, common mode, differential mode, and then 4-11 and 29 and 34, which is voltage dips and interruptions for AC and DC. And finally, we also do the 4-8 and 4-9 magnetic fields. Yeah. So the smaller generator shown up top here, this is the IMU-MGS. This is actually the particular demo unit I'm going to be using today for the demo. The generator can have a maximum of 4 kV or 5 kV test levels. The larger generator shown in the back here is the IMU-MGE, and it can have maximum 6 or 8 kV test levels. The main difference between these two is the 4-12 Ringwave and 10700 telecom surge test is only available in the IMU-MGE. So it's only the larger version, not possible in the smaller version. That's due to space limitations. So that's something to keep in mind when you're trying to configure these test systems. If you might need a Ringwave capability down the road, it makes sense to go with the IMU-MGE chassis instead. I mentioned previously, these generators have a single phase, 300 volt, 16 amp power line CDN built in. For those customers who need to test higher voltage DC or higher voltage AC products, three-phase systems, we offer external CDNs for up to 200 amps per phase, 690 volts AC, and up to 1,500 volts DC. So here you see some images of the generators I was talking about. Again, over here, left side IMU-MGS, and on the right side IMU-MGE. Front panels and rear panels look very similar. It's just size differences, so the configuration is a little bit different. So we have a touchscreen controller. It's a user interface to perform all functions, including test selection, parameter entry, saving, and recalling tests. And then we have a start, pause button, and a stop test button here. Over here on the right, there's a rotary knob for test selection parameter entry. So you can either use the touchscreen controller on the left or the rotary knob for test selection. Of course, there's an on-off button to power up, power down the generator. Following there, we have a USB port. So here you can connect a USB memory stick to copy files such as test setups or test reports from the generator. The USB interface can also be used to update the internal firmware. Over here is an auxiliary connection. So we have an interface for adding external equipment, such as a tethered ESD gun option. So that would be connected over here. And then we have 5 different BNC output connectors. So these are attenuated measurement outputs for direct connection to an oscilloscope. And we have labeled 1, 2, 3, and 4. So BNC number 1 here is the voltage at the EUT power output. So that's the voltage waveform coming out of the EUT power output here. BNC 2 is the current out of the CDN output over here. BNC 3 and 4 are the surge voltage and current measurements. So the IMU generators have an internal measurement circuit built in. So if you connect BNC 3 and 4 to an oscilloscope, you can actually see the actual surge, open circuit surge voltage or short circuit current on the oscilloscope. And then the last BNC over here is an external trigger output. So again, another direct connection to an oscope to facilitate pulse acquisition. Over here, we have a surge high and low output. This is the surge output for direct connection to external accessories, such as 3-phase power line CDNs or data line CDNs. And then here we have the EUT power output. So we have line, neutral, and PE ports for connection to the device under test. So this is the output of the single phase integrated CDN. You can plug in whatever device you're testing here. The CDN couples the surge pulse or EFT burst onto the device under test power lines, but also decouples the pulse from traveling back into the power grid. And then the EFT high voltage output, this is a SHV connector for external accessories like a capacitive coupling clamp or external CDN. And then over here, we have a little ground bar. This is just to facilitate a proper ground bond to the ground plane. It's required for EFT tests to have this bonded to the ground plane. All right, switching over to the rear panel. Of course, this is here where you plug in the equipment. So this is just to power on the generator. In the US, of course, you would just use your standard 120 volt, 60 hertz utility power supply. But anywhere around the world where you have up to 230 volts in Europe or other voltage supplies in Asia, you plug it in here and it works between 100 and 200 volts AC. External variac control. So one of the options we offer is an external variac for voltage dips, interruptions, and variations. So the IMU generator actually controls that variac, and this is the connection cable that gets plugged in here to the variac. On the right, we have an auxiliary connection. This is a safety interlock. So one of the standard accessories delivered with the equipment is a plug, which basically shorts out two pins on here, but you don't have to use that plug. You could also integrate this to your existing safety interlock if you wish. EUT power input 1. So this is a fused input for your EUT power connection. So whatever supply voltage you're using to test your EUT gets connected here, line, neutral, and PE ports. Or of course, if it's DC, you just connect your DC supply. And then again, this is a nice feature here because it's fused. So we have a 400 volt AC DC 16 amp fuse. So it's a over voltage and over current protection fuse. When you're testing your products, if something goes bad and there's an over voltage or over current situation, the fuse should blow before anything happens to the CDN or your device under test. There's a second EUT power input. This is an unfused input. This is used for voltage dips and interruptions. So if you're using an external source, like the external variac, the output of the source gets connected here, and then it's your secondary or your dipped voltage. There's also an option for an internal variac. This one is limited to a little bit lower current. It's rated for 5 amps continuous current. So that's an option that can be installed in a generator. And if that option is there, you have to connect these little jumpers between here. And then on the right, we have some RS-485 interfaces. So these interfaces are used to connect additional equipment that's controlled directly from the IMU generator. So this could be 3-phase CDNs or 3-phase DIPS accessories. And then there's an additional USB port for firmware updates or data extraction. An Ethernet interface. This is used for the remote control software that's offered optionally by EMC partner. And then finally, we have 2 additional BNC ports here. These 2 on the back are actually user configurable BNC connectors. So they can be set as inputs or outputs for functions like trigger input, emergency stop, running state, start or stop test. And then just a couple cooling fans, since this is high voltage equipment. Components do tend to get warm, so we have to make sure we cool them off. All right, so I'll go ahead and switch over to our remote control software and do a live demo. So basically what you're seeing on my screen here, it's a one-to-one representation of the front panel touchscreen controller. So what you see here is exactly what you would see if you were operating the equipment from the front panel. So if I go ahead and select a test here, oh, let me backtrack. So here we have all kinds of different tests listed. This particular demo unit that I'm using today is equipped with combination wave surge and EFT. So these 2 tests are highlighted green, they're activated. Everything gray here is not installed in this unit right now, can be added later, as I mentioned. So this kind of shows an overview of the different tests that can be equipped. So if we go here into the combination wave surge menu, you'll notice how everything is kind of broken down into 4 or 5 submenus for each test. So you always have a level, time, synchronization, and a coupling submenu. And when you click through these menus here, you'll notice that the graphics change. So it kind of helps visualize what aspects of the test you're changing, and it provides an intuitive user interface. So for the level, this is pretty self-explanatory. You enter the desired test level. The range is shown here. So this generator can output anywhere from 250 volts to 5.1 kV surge. And you would just enter your test level there. For instance, 4 kV. Polarity, here you would set it positive or negative. And there are some different automation features built into these generators. For instance, you could have a level ramp. So here I can tell the generator to start at a low level, for instance, 500 volts. and to end at a high level of 5,000 volts, and to increment by 100 volts after X number of pulses. So this is all really programmable how you wish. Um, However many pulses you want to initiate before you jump up in test level. Uh, the step level can be adjusted as well. Polarity alternation. So if I activate this one, then I can tell the generator to switch polarity after X number of pulses. And then for time, here I can enter the number of pulses I want to do. Um, normally the standard says it's 1 per minute. So you kind of have to calculate a little bit how when you're setting up your test plan, how many pulses you want to do on the test. And repetition rate. So this is the time between pulses. Um, Again, usually it's standard says 1 per minute, but for our demo purposes here, we'll do it much faster. And um, the generator needs a few seconds to charge up between pulses, but it's usually pretty fast. So I guess we'll probably do about 2-second repetition rate today, just to speed things up. And then we have a trigger mode, so you can most of the time you'll have it set to automatic, but if you want to manually trigger the generator, you can do that, or you can use an external trigger on one of the B and C ports to trigger the pulse. Moving over here to the sync menu. So this is synchronization. That's a requirement for many tests when you're using AC power. So if I were to want to synchronize onto my AC power line, I would select EUT power here, and I can enter phase angle at which I want the surge pulse to be released. So for instance, I can enter 90 degrees, and the generator automatically detects the power frequency, power line frequency, whether you're connected to a 50 hertz or a 60 hertz power network. So it ensures that the surge is released at the proper phase angle. You could set any degree from 0 to 359 degrees. Uh, Standards usually say you want to test at 0, 90, 180, and 270. But you can enter any angle you wish here, so you have much more capability than the standard actually requires. Another nice feature here is you have a synchronization ramp. So if I activate this, I can tell the generator to um, adjust the synchronization degree after X number of pulses. So let's say, for instance, I want to start at 0 degree and I want to increment by 45 degrees. After 10 pulses, I can do that there. And then moving over to the coupling menu. So for device, if you're testing single phase products, less than 16 amps, you would be using the internal built-in CDN. So that would be internal here. If you had a 3-phase CDN connected, that would be shown up here, and you would select that. And then your coupling path. So this is your coupling paths according to the IEC standards. So we have line to neutral, line to ground, neutral to ground, or your impulse out. So you can also select a multiple coupling automation feature here. So if you activate this, you can select any number or any combination of coupling paths, and you could tell the generator to switch to coupling path automatically after X number of pulses. Impedance. So that normally this is set to automatic, and automatic switches the impedance according to IEC 61000-4-5 requirements, or you have the option to set it to 12 ohm for line to ground coupling paths, and it's 2 ohm for line to neutral coupling path. And another nice feature here on these generators, if you're unsure what a certain parameter means, on every screen there's a little gray info button. If you click on that, it's like a little built-in help feature. So for impedance, yeah, here it says auto will adjust the impedance for IEC 61000-4-5 requirements. So line to line is 2 ohm, 18 microfarad, and line to ground is 12 ohm, 9 microfarad. And automatic will switch this automatically based on the coupling path, or if you would like to manually select that, you can do that as well. And then finally, we have a little measurement tab. So this is basically a peak check for surge combination wave. So if I activate this feature, I can set a voltage or a current amplitude min-max thresholds. So this feature uses the internal measurement circuit and could be useful for checking when protection elements in an EUT are activated. But if you don't want to use that, you just turn it off. And yeah, so that's basically the surge menu, shows all the possibilities how to set up a test. Switching over to EFT, you'll see menu structure is looks very familiar. So you also have level, time, synchronization, and then coupling menus. Uh, in the time menu, it might look a little bit different, but you have a whole bunch of parameters here you can set, and all of these are defaulted to IEC 61000-4-4 requirements. So burst repetition, for instance, set to 300 milliseconds. Click on the info button. Yeah, it says the default and the standard is written as 300 milliseconds. Spike frequency, I can enter any frequency from 1 kilohertz to 1,000 kilohertz. 5 and 100 are only required in the standard. But you have a whole bunch of capability to test at other spike frequencies if you please. So all of these using different spike frequencies and burst duration, so forth. I guess it's could be a helpful tool for product development, troubleshooting, or debugging. But I would say 95, if not higher, percent of the time, customers will just be testing according to the standard requirements. There's no measurement or peak check feature for EFT, and that's a technical reason. It's just because the EFT bursts too fast for the internal measurement circuit to capture properly. So you actually have to use an external EFT calibration loads, 50 ohm and 1000 ohm, to actually properly measure the EFT pulse. So let's go ahead and set up an actual test. So let's do a surge test. And I'll show you, how to set up the test, so run it, and I'll show you the built-in reporting feature. So it's IEC 61000-4-5 surge says to execute a test for AC power ports with 5 positive pulses, 5 negative pulses, and each at 0, 90, 180, and 270-degree phase angles for each coupling path. So let's go ahead and set up one of these tests. Let's take, for instance, a 1 kV test level. So I would enter 1000 volts here. I'll go ahead and activate a polarity alternation. Since we have to do 5 pulses negative and 5 positive, I'll start positive and I'll change after 5 pulses. For test time, let's go ahead and do a 2-second repetition rate to speed things up. I know we don't have all day. And then for synchronization, I'll also do a synchronization ramp. I'll activate this. And I will start at 0 degrees, and since standard requirements are every 90 degrees, I'll step by 90 degrees after 10 pulses. So basically what I'm doing is I'm doing 5 pulses positive, switching to 5 pulses negative at 0, and then we'll increment by 90 degrees, do the same for 90, do the same for 180, and the same for 270. So that's 40 pulses total. So in number of pulses, I'll go ahead and enter 40 for the number of pulses. For coupling, again, I'm using the internal single phase CDN, so I'll leave the device at internal. I'll leave it at line to neutral coupling path and impedance automatic. I won't be using a measurement peak check feature right now. Up top right here, we have a little plug icon. So here you'll see power 1. So it shows I have 120 volts, 60 hertz connected on the fused EUT power 1 input on the back of the generator. Or as you see here, my EUT is not powered on right now. So if I were to switch power 1 on, the grid power, go ahead, it gets switched on to the EUT. So now my EUT is powered on, it sees the voltage, it's going through the CDN. So let's go ahead and start this test. If I hit start here, this is the screen I get. So on the left side, we have a little running log of the test. So again, we're doing 5 pulses positive, switching polarity, um, and then we're incrementing by 90-degree phase angles after every 10 pulses. So it shows your cycle, the coupling path, your test level, or synchronization degree. Again, BNC 3 and 4. So the BNC 3 is your voltage measurement, which you can connect to a scope, or your BNC 4 is your current measurement. You can also connect to a scope, and the remaining test time is listed there. Anytime a parameter shows up red, that means it has changed. So it just highlighted level red, so that means we switched the polarity, or we switched polarity from positive to or from negative to positive, and we also switched the phase angle. I can pause a test, and it's all documented there, and resume it. There's mark and fail features here. So, if you're testing a product and you notice something, you can hit mark and it just kind of shows up in the test report as highlighted. And I can also, if I click the edit button here, I can make on the fly changes. So I can increase test level, or I can, change synchronization angle or coupling path, so forth. So here's my little tabulated test data that I just did. So all 40 pulses. Again, 5 positive, 5 negative at 0, 90, 180, and 270-degree phase angles. Click on more here. I can export this directly to a PDF on a USB stick, which is plugged into the front panel. If I click on PDF, it saves it on the USB stick. Another nice feature here is if you're connected to the internet, so you have an IP address on the generator, so it's listed there. And if you are to open up a web browser and enter that IP address, you can get your test reports that way as well. So it's based on the date and time. So September 29, let's see, 11/29. So I click on PDF there. So this is the test report that the generator generates. All this information here can be edited in the generator, of course. So it's our company name, operator, and the date. It shows the information, serial number, the firmware versions, EUT information. This can be edited. And then it lists out all the parameters that we had selected for this test. So this is 1 kb with polarity alternation activated after 5 pulses, 40 total pulses, synchronization ramp, so forth. Environmental parameters are listed. The power that I have connected is shown there, and all the tabulated test data is shown. So basically, what you can see is, with these IMU generators, the user has a lot of flexibility when it comes to setting up IEC conducted immunity test plans. Um, there are many convenient automation features built in to the system to help speed up testing and reporting. And it's also an internal library, a test center library. So, with the applicable IEC basic standards and some of the IEC generic standards, you can select those. And so all these features really combine to make these really intuitive and easy to use test generators from EMC Partner.